the Debian Astro project. That's the idea to collect software for from astronomy to the Debian project. Debian is as you probably know, is a free Linux-based operating system. It's not only Linux. You have a few parts which GNU Horde or BSD also. It's, however, one of the oldest distributions at all. It was founded 16 years ago. The freeness is free as in free speech, so you can take everything. It's all open source. You can change it. You can use it for whatever you want. We are, I think, the largest distribution, or at least one of the largest. We have 51,000 software packages, maintained by more than 1,000 official developers. That's the largest open source project in the world at all. Our work is based on a written social contract, which mainly says that the software shall stay free and freely available and usable by everyone, and so on. And in principle, to get the developer, one has to sign that contract. That's one of the first steps. We are the base of many derivatives. Well, Debian, as it is not so much used in the world, but what people use is Ubuntu, but Ubuntu is Debian. Just put, well, some specific things on top of that. But all packages we have in Debian and we maintain in Debian, or most of them are in Ubuntu as well. The same for Mint and other distributions. So if one does something for Debian, it will have a huge benefit everywhere. There was an unofficial questioning about which operating systems people use in astronomy, and it turned out that was something like 10% Windows, 50% macOS, and from the remaining part, which is about 50%, there were 2/3 were Debian or Ubuntu. So we have not the biggest part of our cake, but already a quite nice part for what we do there. The current stable version is already 2 years old. It's from 2017. We are in the process to prepare the new version, which is Debian 10, codename is Buster. It's expected to get there in 2-3 weeks or so, or months. We have no schedule for that. The schedule is it's ready when it's ready, and we have a bug counter. The bug counter is something like 70 for release critical bugs. And either they all have to be done, or we decide that they are not so critical, or we kick the packages out which produce these bugs. But that's the question that's always under discussion, and we don't say no. Well, that's we want to have that until August or so. The problem with Debian is that we have, well, it's general purpose, and we have so many packages. 51,000 packages is really a lot. So we find almost everything there. But if you look for a specific field, you're just lost, usually. And that's why what we do is we structure the system by topic. On people doing that, of course. We try to correct it and make a kind of well, environment for a specific field. In my case, in astronomy, we propagate the usage of that there, because people won't use it if the software was not there. The name is a bit funny and had several iterations, and now we are at blend, in the sense of like blended tea, which is a combination of, well, different kinds of teas or packages also, to guarantee that everything fits well together. The rationale from the developer side is that usually people who write software are not, they are experts, hopefully, in their field or in software writing, but not really in packaging. So they may need help in packaging. This is what we do. They get from us, from the packaging experts, they get the feedback from how software integration works. Sometimes they even may do that themselves and become Debian maintainers, and that way we try to make a network of people, users, people developing softwares, Debian developers who package and maintain the software and so on. That's the list of most of the current Debian blends. Well, the first is Debian Astro, which I do. The oldest one actually is Debian Med, which is already something like 20 years old. As you can see, most of them are somehow science related. And we have also a science, specific Debian science blend, which is not really in the other sense, it just collects everything else, but which is in science and which does not fit into the specific ones. And actually, Debian Astro was also part of Debian Science for some time until we started to make that bigger and to make it its own part. There are a few others, which is Debian Edu. For educational stuff, we have Debian Games, Debian Junior, multimedia stuff, ham radio, and it depends on people doing it. Debian is, in that sense, a duocracy. So wherever someone thinks that's important to do, he can do that and put it somewhere there and it will be there. So that's why you find tools there and you find sometimes funny parts there and sometimes very important parts. There's no central roadmap for what has to be done in Debian as a whole. Debian Astro currently has 225 packages, which is, I think, compared to that 50,000, not so less, and especially compared to a small field like astronomy, it's not so bad. We structure them in 19 meta packages, which is, well, some kinds of sections. In principle, it consists of a web page, where all they are shown, and we have task pages on the web page, which show them. I will show that in a moment. We also handle some metadata for all packages that we maintain. We handle the citations of the package. So in principle, if you have installed something on Debian, you can look up what is the how do you cite them. We have a special astronomical software. Source code library is that, which tries to collect all the source code which is floating around in astronomy, and gives IDs for them. We have a good connection to them and maintain these IDs as well. The first release of Debian Astro was done in 2017 with the Debian Stretch release, and the second one will be next weeks, months. That's mainly our landing page. Well, it's introduction and how to install that and so on. That's one of our task pages. I've chosen the virtual observatory here. So in principle, it's a long list of packages which are there, and you can extend every of these lines to get closer into that, to get the actual version, to get the description, a screenshot if it's there, and also all the metadata. The contents are basically, well, I think in the moment we are quite complete when it comes to standard astronomy packages. It took a while, but, well, we have base libraries in C and C++ and so on, which are, well, sometimes quite old, quite matured. We have all the fancy Python stuff that one needs currently in astronomy. That's mainly AstroPy, and the whole AstroPy ecosystem with all the affiliated packages and so on. We also have, which is important for astronomy, legacy packages, which are sometimes more than 30 years old, as IRF, which we maintain. We have Midas, we have Tickle packages, we have a replacement for a commercial software package, which is, well, it's called IDL for the commercial package. We have GDL, We have a lot for the virtual observatory, mainly on the client side, like Aladdin, like Topcat, tools to query the databases and so on. We have a collection of the major radio astronomy stuff, and we have much more. We have packages specific for education, to publish things, for semi-professionals and amateurs, and so on. The team is currently, it's difficult to measure because we are all volunteers from Debian side. So anyone can come and do something, and he can also disappear. So, and that's the question how to count that. The measure I took here is the mailing list has currently something like 170 subscribers. That are basically people who are interested in that. The team members, which are on our development server, they are subscribed 32 people. And actually working and uploading stuff, that's is in the for the latest period, that's 17. But there may be more which are hidden in some individual commits also. That's always difficult to say. We maintain about 180 source packages currently. That's a different number from these 200 something I've shown before, because here's the source package, and you have more than one, maybe have more than one binary package from one source package. For example, one Python 2, one Python 3 package when they were different, when Python 2 was there. And also not all the packages are maintained by us. So we take over packages from Debian Edu team. We don't package the publishing stuff like LaTeX or so. We don't do that ourselves, of course. We just take what is there already. We have a central repository, which is a GitLab instance. That's mainly the base GitLab with a few changes which are specific for Debian. That's always a point of discussion, how much Debian specific that should be. But that will get into a good direction, I think. The one disadvantage is that currently most of our packages have only one maintainer, which means there's a big buzz factor. If that person disappears, that package has somehow to be taken over. And one real problem is that, I maintain 60% of these packages. So when I disappear, there will be a problem somehow because just of the huge number of packages. That's just a screenshot from the development server from the thing. You see, all the packages there, and in principle, everyone can subscribe there if he wants. You don't need anything. You just drop a note on our mailing list that you want to have access to our group, and then you can start writing the package there. There are a few advantages for software to be packaged. The first is the obvious one. It's simple for users to install if they use Debian or Ubuntu or something like that. But I think after a few years, I think that's for the software package not the largest thing, not the most important thing. The most important thing is that we do testing. The first is we are not homogeneous, we are heterogeneous. We have 23 platforms. We have, not only Linux, we have some exotic ones like GNU Horde. We do regularly integration tests. That means every time when I have a software and every time one of the dependencies of the software change, it will be automatically retested. And I get an exclamation mark if that test fails. Repeatedly, that's not so regular, but it happens every few weeks, that the software, the complete build and install process will be tested. And they write bug reports about that. Then we have people who are doing, because the packages all have the same structure. It's a nice thing for software engineer or for software scientists to do software metrics. And they just go through the software and look, are your bash scripts really marked as such, and are they correct? So in a sense, they run a kind of linting for them, which usually upstream doesn't think about. They do something like take all executables and run them with random input. And just don't care about if it works, but they care about, does it crash? Give you a segmentation fault out of that, and so on. And that gives you a number of bug reports which just make the software for the upstream people better. And that, well, they do that for their research, and we get a very nice and powerful feedback to have a good, really good ecosystem behind that. Another advantage is that, well, all that is coupled to the development of the whole distribution, and we care about the dependencies. That means if you have a software which depends on some library, your software will be recompiled and rebuilt in the moment when that software changes somehow the binary interface. And also, and that software will not migrate in our system if it will break my package, more or less. So we try to ensure that everything works together, and that we get early warnings when that doesn't happen. And also, it will not happen that some dependencies, some dependent library will just disappear, because it can't be got out of the system as long as my software is in there. And there will be discussions about if it's quite old and otherwise unused software, how to solve that. But it's not that one wakes up at the morning and says, well, my software doesn't work anymore because one of these, well, Eclipse is not there anymore or something like that. And the last one is, of course, once it's in Debian, it's in many of the distributions which are there around the world. There are a lot of well, advantages also in kind of social meaning. That the first one is we are kind of, well, in a network of the astronomical software community, and bringing software there helps to connect these people. So in principle, I have connections to, well, all the major software developers in astronomy, and also try to bring them to talk together. That when you change something, it may break that software, and please speak together with that. And that's a quite, I think, big impact we have on that field. We hope that the stronger we get, then more people will contribute to our system. People may contribute to our system directly by, well, fixing bugs or reporting bugs. The nice thing is, independent of what upstream does, we are a bazaar style. That means if a bug is found in Debian, reported to us, or in our packages reported to us, we try to fix that. We also try to speak with upstream. If it's an upstream bug, to get it fixed there, and so on. And packages, well, I think I'm a special case for disappearing, but if people disappear, a maintainer disappears in that process somehow, the package isn't lost. We are a team, and the package will be kept maintained by the team. And even if that doesn't happen, other people can step in and just say, okay, I will fix that. And there are people in Debian, especially when we come as now to a new Debian release, which just look through the bugs which are there and fix them, independent of they need them for their own package because they want to have get Debian released. And so it's we have not in astronomy but in other fields, we have some packages which are quite old and which are, well, they don't get updated, but they get kept working for quite a long time, so like 5 or 10 years. So that's That helps quite a lot. And unfortunately, our packages sometimes depend on these packages, and then one has to look to get them in a better state. But it's not as urgent as it would be without that system. And we have a QA team that does the same just on purpose if nobody else steps in. And what hopefully happens is that at some point someone else comes and said, well, I think that package is important, I will adopt it. That's, I think, quite obvious. Debian is kind of very typical Linux. We are not deviating so much from what upstream does. We try to keep close to that. We have high quality standards. We have policies for almost everything. We have a lot of tools for packaging, for package checks, for whatever. Whatever we do often goes either up to the software, and we are highly encouraged to bring patches back to the original software, or sometimes you find them in MacPorts or in Fedora or in other distributions. We have a plan of support older Debian releases, because if once a version is stable, like currently Debian Stretch, the versions are fixed. And only bug fixes, or even important bug fixes, should come there, which is not so simple, but no new versions. We have a specific repository, which is called backports, where we can put new versions, but there's no automated process that needs to be maintained. And due to manpower, it's not really done yet. There is, Ubuntu has the same, but has its own rules there, and that makes a bit more work. There's no specific workflow for that. There's something in NeuroDebian who do that on an automated way, which could be adopted. And we started with that a bit with AstroPy in the moment. But yeah, we are by far not there. And if anyone wants to help with that, I would be happy. As I said, we have a number of rules. First, we have that social contract and the free software guidelines. That is strict. So if a package doesn't fit there, if it's not really free, if it contains proprietary code that can't be distributed freely or something like that, it can't be in Debian. Sometimes it helps, or what we can do is to convince people either to write a replacement code for that or to do that ourselves. I did that several times. And that's in science software hard, because often people don't know that. The software came from somewhere and somewhere else changed that, and then you see, oh, that's code from the numerical recipes. That can't be there. And then you start and say, please replace that code. No, I don't have time for it. But if you don't, then the code is not open source. And then that takes really some time. That is even so in larger organizations. So you find code from ESO, you find code from the National American Observatory, which contains proprietary code. And they complain that's not the case. And then you can, of course, push something, but yeah. Well, we have policies, as I said. Code should be portable. That's not really strict, but it's nice, of course, and it helps to have a good software quality. And we do team maintenance in Debian Astro. Just some pointers. That's more for the record then. Yeah, and thank you. And the last is the names of the uploaders we have so far. They come from all over the world. That's the nice thing. And they do very different things. They are professional astronomers. They are amateurs. They are software people which have no connection with astronomy at all. There are students which just started their thing and want to propagate their own package. So it's everywhere, and that's a nice thing to have a very heterogeneous team. Okay, thanks.
Thank you very much. Who has a question? Just wait a moment.
Yeah, 7 years ago or so, I tried to bring a numeric library into Debian, and I found it difficult to impossible. First, it was technically very challenging to bring it into the required form, and then I had to wait for somebody to sponsor it, and nothing happened. Is there any tendency for that to improve over the last years?
Good question. Well, as I said, we are all volunteers, and we do what we want to do. And if it's a package which is nice to fit for me, because I think astronomy packages are important, come to me, I will sponsor it within a day or so. Yeah, well, there is an improvement. Sorry, that's probably the right answer. There is an improvement. We have a real mentors. We have a mailing list for that, and we have special bugs for that, and they should be done within 2, 3, 4 weeks or so, because there are people dedicated and wanting to look just through them and to sponsor them if possible. But in principle, everything in science should be doable, because the group which does science in Debian is a bit larger than 7 years ago. And if you agree that the package will be team maintained in Debian Science, we will find a solution. So. For C library, that's the question was technically, if you bring a C library into Debian, that's very difficult. I must say, libraries are more difficult than applications. Yes, and we have a number of policies because they should be interoperable with whatever. But well, again, we have a mailing list. Also Debian Science, and there are people, and I promise to help you as well, must say. If there's just something there, drop a note either to me or to the Debian Science mailing list saying what you are doing and how and so, and then we'll guide through that. There's even a mentoring of the month from Andreas Tille. I'm not sure if that's actual, but I think yes. So he says he will guarantee that if you work hard, more or less within a month, you will get your package in there, something like that. And well, he selects that person or so. That's also worth a try in the science team. He has some rules to apply for that because it's his work, but that's something like should be part of the Debian Science team then.
Is there another question? Then I have one. I was looking into Debian back when I was a PhD student. I've been using Debian for about 20 years or something. So way back then I thought, well, being a Debian maintainer would be kind of cool. And I use Debian anyway. So I looked into how much time it actually is, how much time you have to spend actually to be one. And that was quite substantial, at least at the time. You have to read a lot of documentation. I guess that's not different today. So you probably spend a lot of time on that. Is that your free time, or are you allowed to work on that as part of your regular work at the IAP? Because it benefits science also, right?
It is science as well, but I try to use the formula to say I do it in my spare time. So I can't say that I do that in the institute because that's not in my contract.
Exactly.
But well, I'm here during my working time, and the institute actually pays the conference fee. So there is some agreement about that. And actually, for many packages that improved it. So if you have a Python package, which is a lot of development currently in astronomy, well, I'm done if it's a simple package within a day or so to have that complete. The major point is there not the packaging, it is really finding out the licenses. If it's not a small package, but a larger one, to really go through and to say, oh, that was copied from that other package or source from there or something like that. And not just lines, but complete files. And if you have something which is, well, already 5 years old or so, that collects a lot of copyright statements at the end. That has to be done properly, and that's a must. There's no...
So that is you going through that code and...
Well, when I do the packaging, yes. And, well, my part is just going through the code and checking and asking and then communicating with upstream. That's the hard part of that sometimes.